Assalamualaikum warahmatullahi wabarakatuh. My name is Ahmad Mustaffa bin Zakaria and my team member FarahMarinah Binti Aminuddin. Today we would like to talk about the design and the idea of the sustainable technology which can reduce the damage of the environment. Our project is about automatic RFID gateless toll. Okay, about this project, our objective to make this RFID gateless tolls is to design a system that can help reduce the pollution caused by the gases released from the vehicles. Then, we want to reduce the number of vehicles on the road to prevent traffic congestions and to prevent the dangerous health effect from the vehicle gases. Our project was focused on the location which it is located at Plaza Tol Bukit Gambir, Tangkat, Johor. The study will be conducted to test if RFID toll gateless will be effective in combating pollution. As we know, in this modernism and advanced technologies came with heavy consequences. The demand arises in the transport industries causes the number of the vehicles to increase exponentially. So the causes abnormal traffic, especially in the city during rush hour. Study shows that the vehicles release gases such as carbon dioxide, methane, and nitrous oxide, which can cause the greenhouse effect. Next, the gases from the vehicles can cause air pollution such as sulfur, which may cause acid rain. And then the gas such as carbon dioxide trapped in Earth's atmosphere cause global warming. Then the gas also give the bad effect for our lung, also another health disease. Also, traffic congestion may also result in more accident-prone environment. The stress from the sounds from vehicle on road, combined traffic, poor behavior from the drivers. This can be proven when surveys show that Malaysia's death rates on the road rank third globally, even more than China and India. Next is design approach. Based on the issues discussed, we decided to design as the shown above or below. RFID is the identification by using frequency radio. RFID contains three main components, namely antenna, control, transponder, and transceiver. First, when the antenna scan is combined with the transceiver, it forms a component called RFID reader. RFID readers are devices that are connected to a network that can be portable or permanently installed. It uses radio frequency waves to send signal that is active the tag. Once the tag is active, the tag sends the wave back to the antenna where it is translated into data. The transponder tag itself. The reading range for RFID tags varies by factor including the tag type, reader type, RFID frequency and interference in the surrounding environment from other RFID tags and readers. In general, tags with stronger power source also have reading range. As you can see, the diagram shows the flow. When the vehicle enters the highway, sensor detect the vehicle configured to antennas with transponder mounted on the windshield. When the vehicle passes through the exit curtain or the exit line, it is classified electronically by a trader based on the number of the axles, and the ETC account is charged accordingly. Feedback is provided to the driver with an electronic sign. The vehicle is charged. If the vehicle does not have transponder, the system classifies. It has a collector and the camera takes a picture of the vehicle and its license plate for processing. Other information such as date, time, vehicle number may be recorded depending on the data requirements of the toll agency. After encrypting the microwave content, the unit then uses an optical fiber cable, cellular modem, or wireless transmitter of up to 15 to send it to a central location where the computer uses a unique identification number to identify the account for which the toll cost should be deducted. The system uses various technology to work. That's all from me, and for the next methodology, I will pass to my team members.
Assalamualaikum, my name is FarahMarinah. Next, I will present the next slides. This is our drawing prototype. Basically, we have 6 components. The main one are the 3-1, which is the RFID scanner, the camera security with CCD sensor, and the laser transponder. RFID scanner is to detect the vehicle with the RFID tag. The camera security is for security, and the CCD sensor is for image identification. The laser transponder function is to tag the registration plate of the owner and check using the camera with the CCD sensor to check if the car have enough balance or not, or it is stolen or not. Next, for the flowchart of the working system, we can see in this slide. First, when the vehicles come near the tolls will then detect the RFID tag from the vehicle. Then it will check if the vehicle have tag or not. If it yes, it have the RFID tag, it will then read the RFID tag, and it will check it if has enough balance or not. If it have enough balance, it will deduct the amount of the toll automatically from the RFID tag, and it will update the latest amount of the tag at the database. If the tag is not present, the camera will will go to the registration plate. It will take photo, and with the CCD sensor, it will and the laser transponder, it will check at its database, and it will deduct the amount automatically from the bank of the owner. It will also check if the car is stolen or not. If it's stolen, and it will automatically call the authority. Okay, for the financial, I researched this from the US websites, and basically I convert it to Malaysia. So the RFID reader and scanner, basically for one unit is about 254 260 ringgit for one unit, and we use about 5 for 5 lanes of cars. So for cameras equipped with CCTV is 168 ringgit for two for one unit, and we have you use two, which is 336 ringgit. The laser transporter is 292 ringgit, and the CCD for cameras that we will equip this camera is 129 ringgit, and we also buy about 5 of this. So for the service wages and maintaining tools, I look at the Malaysian's website, and I don't know if it's 100% correct, but from what I researched, this is about the minimum, or about the ranges of it for the cost of all of this. Alright, for this next slides, this is our timeline of the project that we done. Basically, this project is about 1 year. We start from 28 June 2019 to 28 June 2020. If we look, the research started at 28 June 2019 until estimatically about July 2019, where we start hiring workers. After hiring workers and negotiate about their wages and so on the September of 2019, the engineer department has started designing how the tools will work, how the component will be uh, installed, and so on. After a couple of months, at December 2019, the installation will now started. For the installation takes about 4 to 5 months, and on the April 2020, after finishing the installation, the electronic installation, the installation of the tools itself, we now will start the beta testing at the April 2020. And after receiving comments and improvement of how we supposed to repair it, we now use the alpha testing, which is on May 2020. After repairing and also listening to the comments on how to improve it, we finally finalized the tools at 28 June 2020. This is our team. I am the head of research and development department. I handle research about the project. I research about the tools itself. What is the advantage of the tools? Uh, why do we wanted to create this tool in the first place? I research about the components, what are the components that's supposed to be used, and so on. I also research and find and also comparing the cost of workers at different companies, which workers that are suitable for to build these tools. And Ahmad Mustaffa bin Zakaria is the head of an engineering department. He is the one who will hire the workers and negotiate their wages, and will be lead the installation of the tools and installation of the electronic components. After that, we will both handle the beta and the alpha testing, and finally the finalizing of the tools. That's all. Thank you to our lecturer, Dr. Noor Ashikin, and our friends. And also, I want to thank my partner, uh, Mustaffa, for this project. Thank you so much.